Today we're going to look at Objective 10 for trig applications. So the first problem is interpreting an equation, and it's talking about the tide levels in Honolulu, Hawaii. And so when we're looking at identifying the amplitude, period, and midline, it's kind of in that order. It's got the amplitude here. It's got the period, well, the B value at least, which will help us calculate the period. And then it's got the midline value here. And so I know that this will be 1.045, this will be 0.95, but we can't forget the y equals because it is a line. And then the period is taking 2 pi and dividing it by the b value. So 2 pi divided by pi over 8 is the same as 2 pi times 8 over pi. The pi's will cancel and you're left with 16. What I mean by units is the measurements that they use. They use hours versus feet. Amplitude has to do with how far up or how far down something goes. So that's the y value. That's talking about the feet. The period is measuring how long it takes for a cycle to repeat. So that would be the 16 hours. And then the midline is that dotted line that goes through, well, it's going through the y values. That would be in feet as well. And then defining this is simply forming some sort of description of the graph based on the word problem itself. So this is amplitude is talking about how far away it is from the average, the max and the min. So how far the high and low tide is from the average. You could also use the fact that it's half the distance between, or the difference between the high and low tide, something like that. For the second one, it's about how long it takes for something to repeat. So there are 16 hours between each high tide and each low tide. You could say it takes 16 hours until it returns back to the high tide or back to the low tide, something like that. And then the midline is just the average sea levels that you would get. So that would be 0.905 feet. When we're finding the values from a graph, it's a similar idea, except now we need to use the visual of it. And so when I'm calculating the midline, I look at the high, which is at 75, and the low, which is at 25. And I add them together and divide by 2. So 25 plus 75 divided by 2. So that's going to be 100 over 2, which is 50. And since this is talking about the temperature, so y-axis represents temperature, this would be degrees Fahrenheit. So this is the average temperature in that city. The average temperature is 50 degrees. The amplitude, well, I've got my two values there. To calculate the amplitude algebraically, we can take the 75 and 25, but subtract them and divide by 2. You're trying to find the difference between them, but only half of it. So that's 50 over 2, which is 25. So the amplitude is 25, and that would also be degrees Fahrenheit. And that's how far away the highest and the lowest temperatures are, or it's half the difference between the max and min temperatures. The period is how long it takes to go from either the highest point to the highest point or the lowest point to the lowest point. There's other ways of calculating it as well, but this is typically the easiest way. So we're looking at the x values from 0 to 12 and from 6 to 18. So that's going to be a period of 12. Yeah, 12. And since the x-axis represents months, we just write in the months. And so it's how long it takes for the cycle to repeat again. So the cycle repeats every 12 months. Miguel is on a Ferris wheel, and he is traveling up and down in the car on the Ferris wheel. I want us to write an equation of this. So I see that this line at the top here is passing through 445, and at the bottom it's passing through 15. So to calculate x minus h plus k. To calculate I like to start with the midline. I'm going to do 445 plus 15 over 2. To calculate my amplitude, it's finding the difference. So 445 minus 15 all over 2. So my amplitude is going to be 230, nope. 445 minus 15 is, oh, my brain is not wanting to work this morning. All right, 445 minus, so that's one, it's 215. And then divided by 2. Yeah, 215. So we're going to have oops. Oh, my thing froze. Okay, great. My pen died. So 215, it's not even letting me write with my pen. So we'll see if that'll be enough. There you go. 215 cosine, and then my b value, well, that's looking at how far apart these two values are. So, and taking that 2 pi, dividing by it. So 8.25 minus 3.25. And so that difference is 5. I'm going to give this another little charge. And so this b value is going to be 2 pi divided by 5, or just 2 pi over 5. If you can simplify, you would take the time to simplify it. That gets a little better. So this would be 2 pi over 5. So then we'd have the x minus the h value. Well, I've got 2 points to choose from if I'm using cosine, which is the typical one I can use because it's the high point. And so I'm just going to use the 3.25 for that starting point. And then when I do 445 plus 15, that's 460. So this will be the 230. And so our final equation is that. For question number 4, you're given a table of values, and on the test you will be given a nice friendly graph, and the values will not be decimal values, so it'll be a lot easier to draw a sketch of the graph. But I did one right now, and it kind of creates a rough sketch of some sort of sine-looking graph. Not the best, not perfect, but something like that. And so what we're trying to do is find the equation between it. So we don't need any of the other values. We really just need the high and the low points to get an estimated equation. This won't be the exact equation. So I'm just looking at the biggest and the smallest y values for this. And so from here, same exact idea. We've got 200 at the top and 25 at the bottom. So the difference between them is going to be 175. Dividing that by 2 tells me the amplitude, which is 87.5. And so again, that's taking the 200 minus 25 and dividing it by 2 to get 87.5. I'll try and go in order this time. So the b value is taking the period, which is the distance it takes to repeat. So it's going to be a little longer because this is only half of the graph going down like that. I need the other half as well. So going from 5 to 11 is a distance of 6, so that repeats twice. So I'm going to do 2 pi over 12, which simplifies down to pi over 6. My starting point, I like to choose the positive cosines, so I'm going to start at the top and do x minus 5 for my h value. And then my last value at the end here is going to be the 200 plus 25 divided by 2. So that will be 112.5. So plus 112.5. And then the last little problem is temperatures over time in a certain state. So we're looking at the city of Washington, or a city in Washington, and probably not true. I don't know. You guys know Washington better than I do. So we're looking at the first month is January. The 7th month is July. So I'm going to be using the 1 and the 7 down here. Its coldest is in January at 18 degrees. So I'm just going to mark that this point that I'm doing is at 18 to help me out. And then the hottest month is at 62 degrees. So 1, 2, 3, 4, 5, 6, 7. So again, I've got a high and a low, so my graph will look something like that, hopefully a little nicer. And so I'm going to be marking out where each of the values are because they do want me to sketch a graph of the situation and sketch it for 2 years. So I'm not just stopping at these 2 points. So let's take a look and see how that'll be. So I'm going to start by first, I think I'll plot all of the points first. So this is going by 6 for the difference. So I'm going to go another 6, and that'll land me at 7 plus 6 is 13. So landing at 13. And then another 6 would get me to 19. And another 6 would get me to, whoops, I did not have enough space, but 25 would be the last one. And so that's going for 2 full years, because 6 months, 6 months, 6 months, 6 months is 2 years. And so for the 13, it's back at the low. For the 19, it's up at the high. And then that means that the 25 is not that low. It's back at the low. Okay, so rough sketch. It's okay if your graph is not perfect. Try and be as good as you can. And then I can calculate the midline by doing, let's say, taking the average. So 18, this was 62. So 18 plus 62 over 2 is 80. Yep, 80. So that means my midline, oh, look at that, it's at 40. And then going from 40 to 62 is a difference of 22. I could also do the 62 minus 18 and divide by 2 and get 22 as well. I hope, yeah, because that'll be 44. Awesome. And you can also see that when I subtract 22 from 40, I get 14. The period, 22. The period is going to be 12. So when I do 2 pi over 12, I get pi over 6. So the equation is going to be the a value, which is 22, cosine of x, oh, didn't do my pi over 6, x minus the h value. So I'm just going to choose this upper point as my starting point, which is at the 7. So x minus 7. And then plus my midline, which is 40. So that's the equation. And then using your equation, predict the temperature in October. So October is the, wow, my brain is not doing too well, is the 10th month. And so I see that I do not have a 10th month on my graph. So I would substitute that 22 cosine of pi over 6 times 10 minus 7 plus 40 into my equation. And so what I'm going to do on the test is, because we didn't spend that much time on calculating values that were not on the graph, I think what I'll do is I'll just choose a point that's a little bit more friendly, but it might not be like 1, 7, 13, 19, or 25. It could be one of the values in the middle. So it could be the 10, the 4, the 15, or the 22, because each of those are just landing back on the midline itself. And so those would all just be equal to 40. The other ones are either 18 or 62. But in this case, we're going to be typing in the 22, I need to memorize this, 22 pi over 6, 10, 7, 40. 22, and then pi over 6, 10 minus 7, and plus 40. Let's see if I got that one right. And so it got me 40, and that's where Miss Hellier says, wait, what just happened? So it should be on the same line. Oh, no, it is. All right, I just said 10, and there's our 10. So yeah, that would be equal to 40. So that's what your equation will look like. And we do want the final answer in a sentence. So the temperature in October will be about 40 degrees. And I think it was using Fahrenheit, I hope. It doesn't even say. How lovely. All right, so that is it for this unit.